Hello, this is an Algebra 2 video. It is Chapter 7, Section 5, and today we're going to be discussing properties of logarithms. And first and foremost, we have the product property. And the product property states that if you have the log, it doesn't matter what base, so you can see that I didn't actually include a base here because it could be any base, but the log of a product, a times b here, will become an expansion basically of log a plus log b. So multiplication becomes addition. It's very important that you recognize that there is no such thing as log a plus b. Sometimes people think that if you have the log of a sum, that the reverse is true, that it becomes a product, and that's not the case. But if you do have the log of a product, it does break down into a sum. So I have an example here for you, log base 2 of 5 times 6. Which would then break down to log base 2 of 5 plus log base 2 of 6. And so we have an example here of how we're going to use this property. And we know that log base 4 of 3, because it's given, is approximately 0.7925. And they want us to use that information to approximate the value of log base 4 of 192. And so the key to this problem is that you first have to break down the log base 4 of 192, most likely to some kind of a product. So 192 divided by, I'm just going to start with 2, is going to be let's see here. We wanted to base 3. I wanted 3 to come out of this. I somehow want to be able to have 192 equal 3 times something so that I can use this property. So I'm going to take the 192 and divide it by 3, and I get 64. So I can rewrite log base 4 of 192 as log base 4 of 64 times 3. And then furthermore, so at this point you could actually take and separate your product into log base 4 of 64 plus log base 4 of 3. Now we already know that log base 4 of 3 is approximately 0.7925, but our other problem is the log base 4 of 64 right here. But again, we can actually take 64 and 64 is 4 to the third power. So we could also write log base 4 log base 4 of 4 cubed plus log base 4 of 3. So we know that log base, the 64 breaks down into 4 to the third power. So at that point, I don't know if you've recognized this or not, but log base 4 of 4, this portion right here, remember that we talked about logs, and the question that you want to know is 4 to what power is 4? Well, 4 to the 1 power is 4. So anytime you have the base and the number here the same, it's going to equal 1. So that's going to be 1 times the 3 here that we've got. It's to the third power. So we're going to get 3 plus log base 4 of 3. And since we know that log base 4 of 3 is approximately 0.7925, we're going to then take and go 3 plus 0.7925, and so our final answer will be 3.7925 as our approximation of log base 4 of 192. So the key to the problems is going to be for you to break down the number here into something that includes the log that was given. So I'm going to let you do this one. And again, they're telling you what log base 4 of 2 is, and they want you to come up with log base 4 of 32. So the goal is going to be to take the 32 and to break it down into a product where at least one of the numbers is a 2 so that you can use this information. All right, so then we're going to go on to the quotient property. And similar to the product property, in this case, when you have a quotient, so division of a divided by b here, and it's going to break down to subtraction, log a minus log b. And again, there is no formula for log a minus b. If you have an a minus b in here, it doesn't convert to a quotient. Only works in one direction. So we have an example here, log base 2 of 5 over 6 breaks down into log base 2 of 5 minus log base 2 of 6. And so in this case, we have an example. It says the pH of a substance is defined as the concentration of hydrogen ions in moles. H is given by the formula pH equals log base 10 of 1 over the hydrogen ions. Find the amount of hydrogen in a liter of acid rain that has a pH of 4.2. So the first thing we want to do is take our formula here, and we know the pH is 4.2 in this case, so we're going to replace the pH here in the formula with 4.2. So let's do that first. So we're going to get 4.2 is equal to log base 10 of 1 over H. And so we have a quotient here, so we're going to use our quotient property to break that down. So we're going to get log base 10 of 1 minus log base 10 of H plus. So basically I took the top and subtracted the bottom, so log base 10 of 1 minus log base 10 of H. And again, before we talked about this, and so the question here with this part of the expression, log base 10 of 1, is 10 to what power is 1? Well, we know that when you raise something to the 0 power, you get a 1. So 10 to the 0 power would be 1. So this expression here gets replaced with a big fat 0. And so you have 0 minus log base 10 of H equals 4.2. And so we don't technically need the 0 there, but we do have negative log base 10 of H. So we divide by negative on both sides. And I don't have space to show it there, but I'm going to come over here and I'm going to get log. So if I divide by a negative, it's going to be a positive log base 10 of H is equal to negative 4.2. And now we can use our ability to rewrite something in logarithmic form into exponential form. So it's 10 to the negative 4.2 power equals H plus, or hydrogen. So 10 to the negative 4.2 power equals H. So now we have written our logarithmic equation into an exponential equation, which will allow us to be able to solve it a lot easier. So now we're going to use the calculator to raise 10 to the negative 4.2 power. And it just so happens that H plus is going to be approximately equal to 0.12345 631. Okay, so basically the calculator says 6.31 times 10 to the negative 5, which means I have to include 5 decimal spaces before here. So 1, 2, 3, 4, I got one too many zeros. Sorry about that. Let's just erase that 0 and put the decimal right there. So we've got 1, 2, 3, 4, 5. So there you go. It's approximately 0.0000631. That's how much hydrogen is in a liter of acid rain, because I'm sure that you were dying to know. All right, so now we're going to have you try this little guy, and then we're going to go to the power property, which is something that we could have used in example 1, and I'm going to go back and show you how that works. But basically the power property is when you have the log of something to a power. So what ends up happening there is that the extra exponent, if you will, the p up here, actually gets moved to the front of the log. So now you'll see it gets multiplied. So now it's p times log base b of m. So in the case of the example here, log base 2 of 6 to the 5th power, the extra power here, the 5, goes in front of the log and it becomes a product. So 5 times log base 2 of 6. And so if you're wondering, if it didn't quite make sense to you before, I want to go back to this example here where we actually did have that situation where we had a power raised to a power. I didn't mention it then because you didn't know about it yet. But basically the 3 that's here comes in front and it becomes 3 times log base 4 of 4. We said earlier the log base 4 of 4 was 1. So 1 times 3 is how we got that 3 there. So now that might make more sense. So going back to our example over here. It says given log base 2 of 5 is approximately 2.3219. They would like for us to approximate the value of log base 2 of 25. So our goal again is going to be to take our log base 2 of 25 and rewrite it in such a way that it includes log base 2 of 5 because that's the information that was given. Well, lucky for us, 25 is 5 squared. So we can write this as log base 2 of, instead of 25, we can go 5 squared. And now it's in the form of this power property. And so the 2 will go in front and it will become 2 times log base 2 of 5, like that. And since log base 2 of 5 was given to us as approximately 2.3219, we're going to have 2 times 2.3, let's make sure I can get this, 2 times, we'll use parentheses, 2.3219, and according to my calculator, 2 times 2.3219 is 4.6438. So that is our answer for example 3, 4.6438. All right, so now you can try this example. Again, just make sure that you take the log base 3 of 49 and rewrite it so that it includes log base 3 of 7, which is what was given. And then we're going to have our last example, which is solving. So we're going to use some of these properties to be able to solve an equation. And so here we have log base 6 of x plus log base 6 of x minus 9 equals 2. So the first thing I want you to notice is that you have a sum here. So you have log, and they have the same base, and they're being added. So that means that it becomes a product. All right. Now this is not to be confused with what I mentioned earlier, because I'm sure someone's already thinking that. What I'm telling you is there's no such thing as breaking up a log of a sum into a product. But if you have 2 separate logs, like you do here, log of x and log of x minus 9, then that is how we apply the property. And so we're going to do that now. So we're going to get a log base 6 of x times x minus 9. That would be the product. Multiply the x and the x minus 9, and it equals 2. So now if you want, it doesn't really matter which order you do this part in, but the next step key is to take the logarithmic equation and to rewrite it as an exponential equation, which would be 6 to the second power equals x times x minus 9. So 6 to the second power equals x times x minus 9. So now you've written it in exponential form, and you no longer need the logarithm, and you can actually go ahead and solve for x, but it is important that you check for extraneous solutions later. 6 squared is 36, and here we want to go x squared minus 9x, and then because this looks very quadratic, we want to move the 36 to the other side, so we're going to get x squared minus 9x minus 36, and I'm going to move the 36 to the side and become negative, and it's going to equal 0. It doesn't matter if the 0 is on the left or the right, I'm going to put it on the right. And so now you have this quadratic, and you can try to factor it. Let's see if that works. X and x goes there for x squared. 36, probably do 12 times 3, because 12 minus 3 is 9. So we want a negative 9, so I'm going to go negative 12 and positive 3 here. Negative 12 times positive 3 is in fact negative 36. And if I use my diagonals, I'll get a 3x and a negative 12x, which will equal a negative 9x, which is exactly what I want, negative 9x. So my factorization will be x minus 12 and x plus 3 equal to 0, which means my solutions are going to be x equals 12 and negative 3. But we want to make sure that we check those for any extraneous solutions. We know that we can't have the log of a negative number, and so right here, log base 6, if I plug negative 3 to that, it will not work. Negative 3 minus 9, again, will be negative, it will not work. So we don't want the negative 3, it's not part of the domain. But the 12 is fine, log base 6 of 12 is totally okay. If I put 12 minus 9, I'll get a positive 3, not a problem. And so my solution then will be x equals 12. It's very important when you're doing these logarithmic equations that you actually check your solutions for any extraneous solutions. So in this case, the only solution that we have is x equals 12. And so now you can do this example, and once you have completed this example, you will have completed your notes for this lesson, and I will see you in class, and thanks for watching.